Okay, so 4.1 is increasing and decreasing functions. And actually, I really say this every single class, but I mean it every time I say it. This whole initial part is just review, but I figure that you may need a bit of a refresher. So to start off with, let's go through the different notations. So if we have, for example, something like this, we have this interval 2, 6, and notice that it's in these curly brackets, or the curved brackets, whatever, or normal brackets, whatever you want to call it. So this is telling us that we're going from this interval, well, I guess there's a few different ways I can write it. I can say it's greater, x is greater than 2, but it's less than 6. Because of the fact that you have the curved or the curly brackets. And this might sound stupid to you, but this is a good way to remember it. You can think it's like the 2 sitting in the curvy bracket, but it can't sit in a curvy bracket, so it slides out, so it's not included. Good? Because it's one of those things with lots of nitpicky little details, so if that helps you to remember. We also could stick this on a number line. So if I were to graph this out on a number line, let's say I made that 2 and made that 6, we know from review from before, we would connect those two to show that it's all the values in between 2 and 6, but it's not including 2 and 6. So that's why we have the open circles at both of those. Review, perhaps we didn't need to go through that, but it's good to sort of get a sense of what this is. Moving on to the next one, notice again just the little tiny subtle differences. This time we have the square brackets. And in the square brackets, you can think of it this way. This time it does have a little space to sit in, so the 2 is included and the 6 is included. So it's almost the same thing, but look at the subtle difference. X is greater than or equal to 2, but less than or equal to 6 this time. So it could be either or. And we still set it up the same way, 2 and 6. We still fill it in or color it in between. But this time we do color in the circles because we do include the values of 2 and 6. I don't even know. Did we need to review that? It's good to have a refresher, but you've probably first learned this maybe in grade 10? Perhaps. You didn't necessarily have to, but you might have just done it in some of your classes. Okay, so then for this next one here, you know how I like to do this. Let's color code it. So that part is in a square bracket, and this part is in a curved bracket. So we have a little bit of both going on. So when we go to work on this or make sense of what's happening, we could say that x is greater than or equal to -2, but it's only less than 7. So we have a combination of both scenarios or both things going on. So when I go to graph this out, I'd have -2 and I'd have 7. The -2 is going to be colored in, but my 7 would be an open circle. And then in between, we would include or cover all the values, but I'd leave those two details as they are. I mean, we could have any combination of all these different scenarios going on, but this pretty much summarizes the different options that you could have. So just pay attention to the look of the brackets because they actually indicate the details of what's going on. Questions? Good? So then, what are we going to do with this? Because we basically were just using that to sort of review and get things set up. We'll do stuff like this. Given this function, f of x equals x to the 6 minus 3x to the 5, over what intervals is f decreasing? Okay, so we haven't quite done this before, so let's go through this together. first of all, if we are looking to see if something is decreasing, we want to find the derivative. So we want to do f prime of x. I usually like to keep things consistent. Since it was given to me in function notation, f of x, then I just do f prime x instead of like dy dx or our other options. It's up to you though. You can do whatever you like, but I just think it's nice to keep things consistent and to be familiar with each of them. And then we know this is a pretty straightforward one. We can do the power rule here. 6x to the 5, that deals with this part when we take the derivative of it. And then we can take the derivative of this part here, and we would get minus 15 when we bring this down and multiply it, x to the 4. So there's our first derivative. So step number 1 is if we're trying to figure out if the function is decreasing or increasing, step 1 is we find the derivative, which we've done here. If it is decreasing, then I would set it less than 0. So I take the first derivative like I did here. We know that that's what it would be when we take the first derivative. And then we want to know where this is less than 0. That's what it's saying if it's asking us when it's decreasing. So there's a bit of memorization or knowing that that's what this is asking you, because that's what this chapter or unit is about. There's going to be a lot of different things to know and understand, like what it is that they're asking or looking for. And then the rest of this would be, working our way through this. So we actually can go about this a couple of different ways. When we look at this, we notice that we can factor things out here. So when I look at it, I can see that there's a 3x to the 4 that I can pull out of here. So I'm going to factor that out, 3x to the 4. And I'm left with 2x minus 5 here. And I want all of that to be less than 0. Okay, so in order to make sense of this, if I want the whole thing to be less than 0, do you see that I have this multiplied by this, and the whole thing has to be less than 0? So I can sort of split this up into different sections. So I'm going to, again, use the color coding to hopefully make this easier to work with and understand. Well, actually, sorry, I'm going to be lazy and just point to it here. Do you see that we have 3x to the power of 4? If I want this whole thing, that times 2x minus 5, to be less than 0, do you see one of them has to be negative? I need a negative times a positive in order to achieve that, right? Can 3x to the 4 be negative? Do you see that it's an even exponent? So there is no way that I could get a negative there. So I'm going to write we can't, or this can't be negative due to that even exponent at the top. Any number I plug in, negative, is going to end up with a positive answer. So really, this is the only one that could be negative. So that's the option that I have to work with. So I'm going to take that and work with it up here because I'm running out of room. So I would have to say 2x minus 5 would be less than 0. And I work my way through the inequality, and you get to see why you learned how to work with inequalities over the years. We bring that over by adding 5. So x must be less than 5 over 2. Do you see that if we're looking at this first situation here, 3x to the 4, is there anything I need to consider or think about when I'm looking at that? If according to this, I need the whole thing to be less than 0, this part helps me to achieve that. If I have x is less than 5 over 2, this part, 2x minus 5, is going to be less than 0. Is there anything that I need to think of or consider when I look at this 3x to the 4? We already talked about how it can't be negative. Is there anything else it can't be? because I need this whole inequality to be true. I need the stuff on the left to be less than 0. It can't equal 0. Good. Everybody see that? So that, and we also need to say that x cannot be equal to 0. Does that make sense to everybody? If I plug in 0 on the left here, 3 times 0 to the 4, that ends up being equal to 0, and 0 is not less than 0, so our inequality doesn't hold true. So we'd want to look at or consider both of those options when we're doing this. So that's what we would give as our answer or our solution. So what do I want you to get out of that? Well, if we're looking to see the interval or the section or the area where it is decreasing, we take the first derivative, and then if it's decreasing, we set it less than 0. So I feel like I don't even need to tell you, but we can do it in the next one. If I have a different function here and I want to know where it's increasing, oh, you don't even need to know this, but we'll do it anyways. This time I don't have it in function notation, so just to give you some variety, we know the first step is we want to find the derivative, right? So this time I can call it y prime. And again, we just work our way through using the power rule with each of the terms, so it's nice and easy to work with. So here we have plus 12x, and that deals with that part. Plus 9, and that deals with this part. And then the constant at the end, we know we don't need to worry about that. Okay, so that's good that we have this, but it's not exactly easy for us to see. Like, we know we're going to want it to be greater than 0, but I'm dealing with, it's way more complex than the last one. But I do, again, want to factor this, so I can break it down into its different intervals or sections on that number line as we were looking at it. So it's probably a good idea for us to start factoring this as well. So I can factor out the 3, x squared plus 4x plus 3. I want to know where that's greater than 0. And then I can even take it a step further. I have a trinomial in here. So we can see something that multiplies to 3 adds to 4. We have x plus 3, and we have x plus 1. So again, you get to see, do you see why I keep saying this course is basically just like a review of everything you've learned over the years? So we need to find the derivative. Okay, that's new for this year. Then we need to factor things out, and then we need to work with inequalities. So really the only one single new thing is the whole derivative part, which by now you're super good at, right? Okay, so now that we have it all split up into sections and we're looking for where it's increasing, we can divide this into intervals. So do you see that we've got, maybe I'll set it up like this. I'm going to sort of do this. I know that I want this part here, so that would happen at -3. And we don't really need to, but I'm just going to draw a dotted line so I can make it super clear to you what we're doing here. So we're like chopping it up into chunks so we can keep track of things. And then we also have this x plus 1. So if that's at +1, then I know that I have, maybe I'll do this and make another little section here. And then we could really, maybe I call that interval 1, interval 2, and interval 3, or section 1, section 2, section 3, whatever you find easiest to work with or to make sense of. And then we test values from each of the regions. So if this is how I'd split up my intervals or my regions, so there's at -3 and -1, then maybe from region 1, I'm going to do this off to the side here, I want to test and find f prime of -4. So I want to plug it into here, and when I plug in -4, I would get +3, which is greater than 0. So basically -4 plugged into here, right? Everybody, we're good with me just giving you that? We find that it's 3, so it is greater than 0, and we were looking for areas where it's increasing, so I can confirm that it's increasing there. Does that make sense? So that's why I've put the check mark. So yes, this is increasing. And then I want to test region 2. When I test region 2, f prime of, I don't have many options. I want something in that, so it's probably -2 is going to be my easiest one to pick, right? Unless I deal with decimals, which we don't want to do. So does everybody see that right here, -2 is probably my best choice? I would take that and I would again plug it into here. So when I plug in -2, -2 plus 3 times -2 plus 1 times 3, I end up getting -1. So this time, no, this is decreasing, so that's not what we were interested in or looking for. And then I want to test region 3. So I'm like physically separating it, showing you so you understand what's happening. You don't have to do that, but I think it's a good way, again, to keep things organized, because I really do feel like a lot of this comes down to organization. So in region 3, we have options, but always go for, or you don't have to, but why not take the easiest one? Do you see that 0 is probably the easiest one? And that's in our region 3 here. The next one here would be at 0. So I can plug in 0, and when I plug in 0, I get to see that this just ends up being 3. Sorry, I've divided that out. I should have told you that. 0 divided by 3 on both sides, just to make it easier, right? So we do find that because it's a positive number, when I plug it in, then it is increasing in region 3. So how do I give my solution or my answer to this? So my answer would be, well, the question was, where is this function increasing? So I know that my answer would include this part, and it would include this part. So the best way for me to write that is, well, if it's in region 1 right here, it would be where x is less than -3. So talking about this part, like in that direction. Is that making sense so far? And then also, I could say, if I'm looking at this portion here in region 3, well, it started here at -1 and it's going in that direction. So where x is greater than -1, it's also increasing in that region. So you don't have to draw the physical regions and dot them and separate them, but do choose your method of what makes the most sense to you. I will say, when it comes to this and a few other things, that oftentimes the mistakes happen over the little annoying stuff. You forgot something, you left off a negative, you did -1 instead of +1. If you do take the extra 5 seconds to sketch it out, and it'll bring you clarity, and it'll eliminate or minimize those little mistakes. There is your work. Sorry, that's not supposed to be 1.2. That's supposed to be 1 and 2 on page 163 and page 171 to 4 all.